Alright, so I finished grading programming assignment 1, so excellent work on PA1. This was a delight to grade. I don't say this every year, but I'm saying it this year. This is by far the most success I've seen people having with programming assignment 1. Everybody nailed it. Even the cases where someone wasn't able to get their program to run completely, it had, all the essential elements. The inner loop looked great. A few details here and there, but a number of assignments that were absolutely perfect, which really doesn't happen usually, particularly at this point in the course. So really good work. Lots of use of functions, which is nice because I usually spend the middle part of this course trying to get people to use functions in C, and a lot of people were using them in Bash already, so that's excellent. That's going to help with all the development down the road when we're trying to be modular and do code reuse and so on. So yeah, really great work. And Git, obviously everybody was able to submit on Git, so so that part of the task is working fine. So yeah, I was really happy with what I saw. So I gave you feedback if there were things that I took off points for. I let you know what those were. And if you have questions about that, you can ask for more clarification. But by and large, it looked like people had the stick program working, which means presumably that PA2 is not going to be a big deal as far as algorithms, right? So it's mostly about dealing with the C part of it, which we're going to start talking about today, and which your ODPs are going to work on. So today I want to talk a little more about sort of customizing Linux environment. I want to go through the ODP and talk about some things related to doing input in C, and then I want to go ahead and start doing a quick overview of VI, sort of give people some ideas of some more things we can do in VI besides just moving around with the arrow keys like in gedit. Before we get into that, questions up to this point? How many people started PA2? Cool, awesome. What are we up to? 409. All right, so ODP 409. This is a modified version of 408. 408 was a C program that took a command line argument, and I said you can assume it's present, it's a real number, and it's not negative. And then your program is supposed to print out the square root of that. So if you say ODP 408 16, it should print out the number 4. Okay, ODP 409 is exactly the same behavior, except it's got to deal with error conditions. And so there's 3 possible error conditions, well, 3 possible states. The first state is you don't actually give it a command line argument. Either there's no argument given, or you give it multiple arguments. So if you run this exactly the way that you're supposed to, right, S1, and you give it a number, it prints out the square root, and you're done. Okay, if you run it without a command line argument, or you run it with multiple command line arguments, it should print out ERR, error. Okay, so that's the first error condition you want to check for. Not exactly one command line argument. Either no arguments or 2 or more arguments. Just print out ERR. Doesn't matter if the first one's a number or a negative or a string. Right? Not exactly one argument, print out ERR. So that's your first check. If there is exactly one argument given, but it is not a valid double precision number, then print out INV, which means invalid. So S1, a single number, but it's something like, XX, that's invalid. Oh, my bad. I'll fix that. Shouldn't do that. Okay, it's got to be a valid double precision number. If it is one argument present and it's a valid double precision number, but it's negative, right, then you print out NEG, negative. Yes?
So what's the difference between 5009 and 10?
So 5009 is an error because it's not exactly one argument. Okay, so the first thing you're checking for is there exactly one argument? And if there's not, then you print out ERR. If there's one argument but it's not an actual number, you print out invalid, INV. If there's an argument and it is a valid number but it's negative, you print out negative. So let me flowchart this for you. So if there's not exactly one argument, that's an error. If there is one argument, is it a number? And if not, that is invalid. And if it is it greater than or equal to 0? And if not, it's negative. So there's a flow chart if you like. Check to see if there's exactly one argument. If there's not, print out error and you're done. If there is one argument, see if it's actually a number. If it's not, print out invalid and you're done. If it is a number, see if it's bigger than or equal to 0. If it's not, print out negative and you're done. Otherwise, print out the square root. So your whole ODP is basically one big if statement. All right, so questions about that? So how do we tell whether or not you have exactly one command line argument in a C program?
ARCC.
ARCC. I go to my own machine. All right, so here's the prototype for our typical main program. What do we expect command line arguments? If we don't expect command line arguments, we just say main paren. So if you want to know what argc is all about, write a piece of test code. Okay, this program does nothing except print out the value of argc. So if I run test 1 without any arguments, it says argc equals 1. And if I say test 1 and I put in a 16, it tells me argc is 2. Test 1, ha ha ha, argc is 2. Test 1 anything and it tells me argc is 2. Why? Because there's two things on that command line. There's test 1 and then there's some argument that I put in. Test 1, 2, 3, 4, argc is 4. Why? Because there's 4 things on there separated by spaces. Test C, quote 234, argc is 2. Why is that? Because the bash shell sees anything inside quotation marks as a single thing. This is a single string that happens to contain spaces, but the one argument is this string 234. So there's two things. There's test 1, and then there's this string 234, so argc is 2. Alright, test C is 11. There's 11 things on there. There's nothing more to argc than that. It's just the count of the number of arguments. So how could we tell if we had exactly one command line argument in our ODP? What should we check for?
argc is equal to 2.
Just see if argc is equal to 2. If argc is not equal to 2, print out ERR and return. And it's a pretty simple flowchart, but it will really help you. I can't tell you how many different ways people might end up coding this ODP that are not correct, because they're doing something different from this. For example, first they're checking to see if this thing is a valid number before checking to see whether or not there is an argument. Right? That's going to give you a seg fault. We're checking to see if it's negative before they've checked to see if it's actually a number. So check to see if there's one argument. If argc is not equal to 2, print out ERR and return. Close curly bracket. Done with that. Okay, now we're here in our flowchart. What do we want to do? We want to know if the argument is a number. So how do we tell if an argument is a number or not? What is this argument anyway? What is argv about? And by the way, argc is not magic. Right? It's just a variable, like a variable in any other function, and it's just a placeholder for whatever that first thing is that goes in. So I could say integer haha, and this will work the same. Right? So it doesn't have to be called argc, but in almost every instance imaginable, you're going to want it to be called argc. Certainly if you're writing code for somebody else, call it argc first time out. And argv is the same way, it's just a variable. Alright, so char star star argv. So if I say integer I, what is I? It's an integer, right? If I say integer star I, what is I? It's a pointer to an integer. And one way I like to think of this sometimes is like this. I is a variable of type int star, where int star is a pointer to an integer. So it's not like we're declaring a variable called asterisk I. We're declaring a variable called I, and the type of that variable is int star, which is a pointer to an integer. And so if we say char star C is a variable that's a pointer to a character. Okay, int star I is also how we say we have an array of ints. When you have a pointer to an integer, it's also an array of integers. When you say char star C, C is actually an array of chars. So imagine that I did this. Char star star argv. Char star star argv, this should be a pointer to a char star. And a char star is an array of characters, which we also think of as a string. So char star star argv, that's like saying string star argv. String doesn't exist in regular C. But if we imagine that char star is the same as a string, this is a string star argv. It's a pointer to a string. And a pointer to a string is just an array of strings. So char star star argv basically says argv is an array of strings. That's motivational, if not entirely accurate. So we can print out the value of argv bracket 0 as a %s, because we know that argv is an array of strings. So argv bracket 0 is the first element in that array. It must be a string. So we can print out argv 0. And let's just print out the first few of these. Well, that wasn't what I expected. Oh, I gotta get rid of all this stuff. Tell you what, I'm gonna comment all this out. Say again. Print out.
No, I think you're right.
I think that's okay. Yeah. Okay. So test 1. This is a long line, and I messed up my numbers. So argc is 6, and the first argument is test 1, which is the name of the program, and then this is long. Let me fix my numbers in the print. Okay. So does this make sense? The output here? I've got 6 arguments. I printed out the first 5 of them, right, which is element 0 through 4. Suppose I don't have 5 arguments. Suppose I just say test 1 and I put 1 argument on here, which is 25. argc should be equal to 2, right? The first element should be test 1, the second element should be 25. The third element, argv bracket 2, it's telling me is null. I'm lucky because all I did was print it. If I tried to scan it or something, I would get a seg fault. And then there's this fourth element, which is less close equals blah 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 less pipe, whatever that is. And this fifth element, which is xdg menu prefix. And those aren't command line arguments, they're other stuff. So here's something really important. When you're using argc argv, make sure that you check argc before you start doing anything with argv. If argc is 1, you have exactly 1 element in the argv array. That's argv bracket 0. And you can look at that, you can print it, you can scan it, you can copy it, you can string length it, but do not do anything with argv bracket 1, 2, 3, 4, 5, or anything else. If argc is 5, you have exactly 5 elements in your argv array, so you can work with argv 0, 1, 2, 3, and 4. Don't touch anything outside of that. Okay, if you do, chances are you're going to get a seg fault. Best case. Worst case, you're just going to be working with random data that's something different from what you think. So it's really important to look at argc before you do anything with argv. You had a question?
Oh yes, can you go back to the C file again? So you didn't declare what is RV, right?
Yes, so here I committed a grave error, which is I ignored the value of argc and started printing values of argv.
Oh, so before that RV have chart the 2 signals, so it already means RV is array of strings.
Yeah, so all this stuff is commented out up here, right? That's just comment. So my code actually starts here. So a better way to do this might be something like Better way to look at argv might be to put it in a loop where we run I from 0 to argc minus 1 and print out each element of argv. Alright, so we have 10 arguments, we can look at all 10 of those. If we decide to ignore this and just check like the first 100 some elements, right, we eventually get a seg fault. We made it all the way through the first 64 elements of argv, but it will eventually seg fault you. But there's interesting stuff in here. I found my login name, argv bracket 53 had that. What else? There's my shell, so I know I'm using bash. There's my home directory. There's the directory that I'm sitting in, and there's potentially good stuff in here. My username, some information about my SSH security. So this stuff is available, but technically we shouldn't be using it, right? And if I do this on a different system, I might actually seg fault when I get to argv 11, maybe argv 10. But if argc is 10, you can use the first 10 elements of the array safely. And these things in argv, they are strings. Even if it's a string containing the number 4 or 2, it's not an integer. It's a string containing a 4 followed by a 2 followed by a null terminator. So we can't do something like, say, take the square root of argv bracket 1. Right? That won't even compile. So let me get rid of these now. Right? All kinds of complaints here. And the error is actually kind of useful here. It says incompatible type for argument 1 of square root, and it's pointing to argv bracket 1. Right? Argv bracket 1 expected a double, but argument is of type character. Right? It's a string. You can't take the square root of a string. Square root expects a double. So what we have to do is we have to do some kind of conversion. We have to do something to change this string into a double so that we can take the square root or increment it or do whatever we want to do with it. And so how do we convert things from a string into, say, a double or an int?
Cast?
Cast is technically correct, but it's a slightly different thing. Cast actually says this thing really is a double to begin with, but it's being treated like something else. So just take the bits in this thing and pretend it's a double. So we can cast, for example, a short int to a long int. We can say just take these bits and treat it like this other thing. But the bits for a character 4 followed by a character 2 are different from the bits for an integer 42, which are different from the bits for a double 42. So how do we do that conversion? So sscanf. So sscanf is like scanf, but it takes the first argument, which is a string of characters, and instead of reading from the user input, it reads characters from this string. And then it tries to convert them using some sort of format string, which is the %s, %d, %f, that kind of thing. And then we list whatever outputs we want to save those converted values into. And so a typical use would be something like scanf argv bracket 1, quote %lf, address of num, where num is a double. Alright, so same thing from ODP 408. Here's a string. Let's start at the beginning of the string. See if you find this double precision floating point number. And if you do, convert those characters into a double and then save it at the variable whose address is given here. Well, this is the address of num, so it'll save that result into num. Okay, so there's a warning in here. We should have made sure that argv1 was meaningful, meaning that argc was at least 2, before we actually do this sscanf. But I'm just going to assume that we've got our argument given, and we're going to scan it into num, and we'll print out the value. So let's print out num and the square root of num. Your math library. So if I say go 16, it says the number it scanned was 16, the square root was 4. And if I go -4, the number was -4, the square root was negative, not a number. If I say go ha ha, it tells me my number was 0. Right? And that's not really what we want. Really, we wanted to detect that this was not a valid number and print out a different message if we're doing the ODP. So scanf does two things for us. One, it will convert something from a string to some other format, like a double. But two, it will also tell us whether or not it succeeded. In other words, it will check to see if this thing is, in this case, a double. And if it is, it will convert it and store the result in here. If it's not, it will also tell us that. And the way it tells us is by supplying a return value from the scanf function. So sscanf actually returns an integer, and you can look at the manual page for it. And the manual page always has a section for return value, and it might be pretty far down. So return value. On success, these functions return the number of input items successfully matched and assigned. This can be fewer than the number provided for, or even 0. It can also be negative. So it tells you the number of things that were successfully scanned and converted. So up here I'm trying to scan and convert one thing, one double, into num. If it succeeds, then sscanf should return the number 1. If it returns anything else, something went wrong. So when I call sscanf, I'm going to save that return value in an int. And let's print it out. Okay, so return value is different from num, for example. The function is returning a value to num in this case, right? But when you say return value, that means something very specific. It means the value that is the value of the function. So if you say variable equals function or print function or something like that, the return value is the value of this right-hand side. Okay, it's not just an argument that happens to be returning. So let's print out the return value of the function. So in this case, the return value from scanf was 1. That's good. If I say go hello, the return value from scanf is 0. That tells me I did not have a valid double. It was not able to do that conversion. So in my flowchart down here, what I'm doing is I'm calling sscanf and I'm checking the return value. And if it's not exactly 1, it was not a double number. I can come down, I can print out invalid. If and only if it returns 1, and I already checked and argc was exactly equal to 2, then I know that I have a double, and now I can say, is that number bigger than or equal to 0? So that's just an if. If it's less than 0, then print out negative and return. Otherwise, go ahead and calculate the square root, print it out. And if I just go, I get a seg fault because I didn't check to see if argc was equal to 2 before I tried to use argv bracket 1. And down here I'm trying to scan argv bracket 1. Argv bracket 1 is null. Right? And I would avoid that by checking to make sure argc is bigger than or equal to 2 before I do this. If I say go and I give an argument, so I do have an argv bracket 1, but it's an empty string, scanf returns -1. That's a special error code, meaning that you asked me to convert something that had no characters in it. So you don't ever want to say if scanf equals 0, then there's an error. The correct way to check to see if scanf succeeded is it equal to 1 or is it not equal to 1? If you want to check for an error in this case, if the return value is not equal to 1. Or if you're trying to convert 3 things, make sure that scanf returns 3. 3 or not equal to 3. Don't say if it's equal to 2 or 1 or 0, right? So equal to 3 it succeeded, not equal to 3 it failed. Does that make sense? All right, so that's more than enough to do the next ODP. And we're not going to use scanf in this class. We're going to stick to sscanf, and we'll talk about why later. But if I say scanf, I usually mean sscanf. Yeah.
For the PA2, you want user only. You want to be able to differentiate between doubles and integers, right? So
yeah.
You want the user to input like 19.2.
19.2 should give an error.
Okay.
Yeah.
Okay. Am I allowed to use string.h?
Yes. You've got to use scanf and stuff. All right. Any other questions?
Are you going to upload that code to Canvas?
This one?
Yeah.
Sure. All right, let's shift gears for a minute, and we'll come back to talking about scanf and fgets and how to parse and stuff like that later. But let's shift gears. Let's talk about using Linux a little bit. And I talked about some of this already. Did we talk about tab completion for matching file names? Okay, that's the biggest thing. That and using the up arrow to pull back a previous command, using Control A to go back, Control arrow to go forward or back, and so on. Let's talk about Linux access. So if you have a Linux machine, you're all set. You can do all your work on your Linux machine. Just make sure before you submit something that you push it over to the Linux server and that it works on there. Because there's sometimes differences in what the default version of C is and so on. And I test on the Linux server. But you know, as far as working with Linux and practicing and so on, if you have Linux on your own device, that's sort of your ideal option. You can use the Linux server itself if you have network access, so that works well. If you don't have either of those, if you have a Windows system and you don't want to have to rely on Linux on network access, there's a package called cygwin. If you just Google cygwin, it'll take you to cygwin.com and you can click through on that and set up x86 64.exe, assuming you've got a 64-bit system. Click on that, and it will save a small install file that you go ahead and run, and it's basically going to create a file, an executable program on your system that is a whole Linux implementation. And it's not a dual boot. It's not something that overwrites your OS or that runs alongside it. It's just a program. It's a Windows program. But it's a big program that basically is a full standalone Unix system. And I used this for years when I had to use a Windows machine, but I wanted Linux access. I just ran cygwin, and that was where I basically lived. I just started a bash shell and did all my stuff from there. You can do compilation, you can do text processing, you can do debugging, you can do all the stuff that we're going to have to do in this class and 222 and probably a good chunk of 223. You can do it from cygwin. And you don't have to reboot, you don't have to hop onto the net or anything like that. It's local to your system. You can share files with Windows and so on and so forth. So it's a really, really good solution if you want to have Linux access, but you're living in a Windows environment. It takes a long time to download and it takes a long time to install, as in like 12 to 18 hours. So you don't want to do this like in between classes. You want to do this like started when you get home and let it run overnight. Okay. And it doesn't necessarily restart very well. The download takes a while, but downloads are pretty solid, but then it takes a long time to install. But go ahead and download that executable and run it and follow the instructions. And there's one trick that you need to know to make it really do what you want, which is when you're going through, there's a few things you have to do in the beginning and then it just kind of runs on its own. One of the things, you'll get a screen like this and it says select packages to install, and it will look like this by default where everything is set to the default settings. Okay, you want to go to this first symbol next to the word all, in between all and default. It's a pair of arrows pointing at each other. You want to click on that and that will change default to something else. It will cycle through a set of options. What you want to do is cycle through to where it says install. And when it looks like this, then when you go ahead, it will install everything in cygwin. And that's really what you want, because the normal version is really for people who want to use Linux but don't want to do development in it. So you get games and you get utilities, but you don't get GCC and GDB and all this other stuff. So if you set that to install, that basically puts in everything. And all these packages will get loaded. And then you've got full-blown Linux. So that's a good option. If you have a Mac, if you're running OS X, you already have Linux. Okay, OS X is Linux. And so you can open up a terminal window, you can do GCC and so on and so forth. Now depending on your installation, you may have to download and install some new packages to make some things work. but it's basically a Linux back end. If you're on a Chromebook, you can download Crouton and follow some instructions online and actually bring up a Linux shell, and that works pretty well. What else could you be in? Okay, and so in Windows there's a bash shell built in also that you can get to. If you decide to use that bash shell, I'd be interested in knowing your experience. I tried it when it first came out, and it was kind of a little flaky, and then they officially released it and I tried it there, and it mostly worked, except that every now and then it seemed to sort of reset itself and I would lose everything. So I haven't messed with that for a year.
Are you talking about the subsystem?
Yeah.
Yeah, that's what I use.
That's what you use? Any problems with it?
Not
Okay,
yet.
cool. So
I
that,
run Ubuntu as the app that
Yeah.
accesses it, and it's been fine.
okay, cool. So that's another option, bash built into Windows, because they're actually officially including that as a part of Windows now. Another option is VirtualBox, or some kind of virtualization. So most operating systems, Windows, Linux, and so on, let you run virtual hardware emulators. So VirtualBox is a good free one that basically it pretends that it's its own machine. And you can install your favorite operating system in this virtual environment. And again, it's just another big program that runs underneath your OS. And so you can use VirtualBox to install, for example, your favorite distribution of Linux, Ubuntu, Mint, whatever. And then when you run this in Windows, you've got your whole Unix environment and all the graphics and things like that work. When I've used this before, the hardware seemed to play really well as far as networking, USB devices, external drives, all that seemed to work seamlessly. So that's another option, is using some kind of virtualization. So those are the main ones that come to mind. So lots of ways to get Unix access regardless of what system you're running. So if you're on Windows and you're trying to connect to the Linux server, there's a good chance you're using PuTTY. And PuTTY doesn't actually run under Linux, but I'm emulating a Windows environment in Linux. So here's PuTTY configuration. I just want to mention a few things here. Up here under host name, you can put in your username at linux.engrcs.com, and you can type in here default settings and say save, and that will be the default, right? Every time that you open up PuTTY, it will open with this window and your username and the host name will already be filled in, and all you have to do is hit enter and it'll automatically take you over to the Linux machine. So if that's the only thing you're doing with PuTTY, that saves you having to type that in every time. And you can do other things. So under Window, you can come down to Appearance, and for example, you can change the font that's being used. So I like a big font, so I set it to 22 point instead of 10 or 12, so it'll come out bigger. And you can set it to bold if you like. You can come down under Colors, and you can set your default foreground and background. So I've got my foreground set to green and my background set to black, and you can pick colors off of a palette like that. Under Window, lines of scroll back, normally this is something like 1,000, right? So you get that little scroll bar on the side of your PuTTY window, you can go back and see previous commands, previous output, right? Make that large, make it like 1,000,000, right? Memory is cheap. And it will remember, effectively your entire session, unless you have more than 1,000,000 lines of input and output per session. That's useful. Right? There's occasions where I've lost my work, but I've been able to scroll back to 2 days ago, and there was a copy of some time when I displayed my program, and I can just copy and paste from there and get back most of my code. It's nice to be able to scroll back. So you can customize all of this, right? And then go back to your session and just save it as default settings, and it should open up with all of those bells and whistles. And it's just one of those things that, you know, you could do it every time that you log in, but you can set it up once and have it done. The other thing is this bash RC file, which you can customize. So we talked a little about prompts, right? You can set PS1 equal to whatever, and it will make your prompt whatever that string is. And there's special things you can put in, like !! Exclamation mark tells you the number of the command and so on. There's all kinds of color settings, which I removed from here, but if you look at yours, there's ways to turn on color coding, there's ways to turn off color coding. Okay, I find color coding distracting personally, just because I didn't grow up with it. But if you don't like the color scheme, you can modify it, you can change it, you can get rid of it completely. Right, so all this stuff is modifiable. I set my history, my command line history size to 5,000. I've got aliases set up to execute commands that I run frequently. UMask lets you specify what the default file protection is on files you create. I've got mine set up so that nobody has access except me. And so on and so forth. So be thinking about things that you do frequently in your environment that you'd like to set up to happen automatically, or things in your environment that are annoying to you that you'd like to change. Right? There's a good chance there's ways to change them. And it's all good practice, right? It's all good practice at using Linux and figuring out what commands do and so on and so forth. All right, so tomorrow we'll talk about the next ODP, and then we'll start talking about VI. And I want to spend at least today going through VI and sort of power usage of VI. Just some more of the commands. Again, small piece of the full set, but more things that you can do in there that might be useful. All right, see you next time.